Okay, so this is Oaktobotics system review and proof of life video for NASA. So right now we have the robot assembled partially. What we have right here is we have the digging system. We'll explain that in a bit. And then we have the chassis, which is complete, and the drivetrain, which is also complete. And right here we have a cutout for the hopper. Which is going to be carrying the regolith from the excavation site to the dumping bin. So right now we're going to demonstrate what's going to happen and how everything moves. So right now we're going to demonstrate how the arm moves. This is the arm and the gearbox that moves the arm, so you can plug it in. I'm going to hold it, you can plug it in.
All right, so this should make the arm move a little bit forward.
That's backwards. So this is forward.
And this is backwards.
So that's going to be the movement of the arm. Do you want to explain?
And then, yeah, so that's going to be the movement of the arm forward and backward, kind of like we're dumping. These two will actually be moved from here so that it actually gets the full range of motion downwards. Next, the 360 of the arm is driven by this gear right here, the Lazy Susan, and that is going to look like this, that way, and this way. And it does rotate 360 degrees. The gear, the Lazy Susan over here, that actually has the motor attached to it on the bottom, is going to have a 90 degrees so that it doesn't actually interfere with the regolith upon actually entering the competition. And that should be the whole range of motion for the arm. This will actually occur from the linear actuators being mounted on the ends of these two shafts here. And that's what actually is going to make it go up and down like so. And then the bucket is going to be moved by two more linear actuators. This is a four-wheel drive, so all-wheel drive. Each individual motor is actually connected to each individual wheel. And now I'm going to show you the range of motion for the front wheels right now. So this is wheel number 1. This is wheel number 2. And these also, obviously, in the same fashion, they also do that. I just can't demonstrate that because it's currently on the floor. But yeah, so this will also have a 90 degree on it, and that is currently our full drivetrain. So 4 motors, 4 wheels connected to plates, and that is what drives our robot.
These are the robot's electrical components. This is the Raspberry Pi 4 Model B. We're using ROS as our software frameworks, and Python as our primary programming language. These are the Sabertooth motor controllers. This one is 60 amps and this one is 25 amps. The Sabertooth motor controllers are used to alter the movements of the drive motors and the linear actuators.